In this lesson, we're going to look at vertical stretches and vertical compressions. To start this lesson, let's go ahead and look at this example. So this is the function of this is the absolute value function, and I'm going to go ahead and label this as I'm going to go ahead and use this color. I'm going to go ahead and label this as f of x is going to equal the absolute value of x. All right, so that's the absolute value function that you see here. Okay, now if I wanted to graph, let's say g of x, and I'm going to use a different color. So let's say I want to graph g of x, which equals 2 times the absolute value of x. Or in this case, we could say g of x equals 2 times f of x, right? Because f of x is the absolute value of x. So this right here, f of x is equal to absolute value of x. So remember what f of x is. So f of x is that y value. And so if you remember, if you think about it, so whatever that y value is, so when whatever x is, and you look at that y value, you're going to take that y value and you're going to multiply it by 2, right? So basically what that means is this. If I take I'm going to go ahead and label this. If I take this point here, 1, 1, and then take this point here, let's say this is what, 3, 3, and then 4, 4, and so on. And let's go ahead and use on this side, let's use the coordinates of this point here is -5, 5. And over here, let's use this one here. So that will be -3, 3. Okay, so I'm just going to look at those points, and there are an infinite number of points we could use on this graph. But if I take each of those y coordinates right here, and by the way, the vertex of this absolute value function is 0, 0. But if I take each of those y coordinates and multiply by 2, I'm going to get this point. And I want you to notice that is making sense, because if I use a t-table as well, you will see this. So for example, when x is 1, 2 times the absolute value of 1, I'm going to put this right here, 2 times the absolute value of 1 is 2, right? So look what's happening. So I'm taking that y value, which is 1, multiplying by 2, and I get 2. So I could either use these y values here, or I could use a t-table. But the point being that when I multiply this y value by 2, I get the new point 1, 2 right here. Okay? If I do the same thing with 3, 3, so my y value is 3. If I multiply that by 2, I get 6, don't I? So I'm going to get the point 3, 6. So that'll be right here. Okay? Right there. So 3, 6. And if I take the point 4, 4, take that y value, which is 4, multiplied by 2, I get 8. So my new point is going to be 4, 4, 8. I'm sorry, right here, I'm sorry. This point here, it'll be 4, 8. So 4, 8 is right here. Okay? And so using a t-table, I want you to see that does make sense. So when x is 3, right here, when x is 3, I better get the y value 6, right? So let's see. 3 times the absolute value, 2, times the absolute value of x, and x is 3. So I get 2 times 3, which is 6. All right, so when x is 3, my y value is 6. When x is 4, I get, right here, I get 2 times the absolute value of 4. So that's 2 times 4, which is 8. All right, and so notice I do get that. So 4, 8 is right here. Same thing on this side, except I'm not going to do the t-table anymore. I'm just going to use the fact that this says I take that y value and I multiply by 2. So this y value is 3, right? So my x is -3, my y value is 3. So I'm going to take this 3, multiply by 2, and I'm going to get the point -3, 6, which is right here. And then if I do this one right here, -5, 5, take that point, which is right here, right? So -5, 5, take that y value, which is 5, multiply by 2. 5 times 2 is 10, so I get -5, 10, which is about here. Just want to make sure I put that in the right spot. All right, and then if I use a ruler and draw, oh, and by the way, the y value here is 0. 0 times 2 is still 0. So the origin stays the origin for the vertex. Okay, so let's go ahead and draw this graph. Let's see. We're going to get something that looks like this. Okay, do the same thing on this side. We're going to get something that looks like this. And the whole point is this now. I want you to notice something. Okay, so I want you to notice. So the red graph right here is g of x, which is 2 times f of x, right? That's that red graph. G of x, which is 2 times f of x. So I want you to notice that this distance right here, see this distance from the x-axis to this point here, that distance is 2, right? What is this distance from here to here? It's 4, correct? Okay, if I look at this distance here, that's 3 units. Over here, it will be 6. So you see that I'm doubling that distance. So this distance is 3, this distance is what? 6. Over here, from the x-axis, this distance is 4. 1, 2, 3, 4. 4 units from the x-axis, right? From this point to the x-axis. If I double it, this is what that says, I get 8. And notice that from here to here is 8 units. Okay? So whenever you're increasing the distance by a factor, so you're increasing that distance. You're increasing that distance. What's happening is that you're stretching. So this absolute value function right here is being stretched. So you're stretching it. It's like taking a rubber band and stretching it. Okay? So it's being stretched. So this is a stretch right here. That's a stretch. So you're taking this and you're stretching it. You're stretching it to make it, and it kind of looks a little bit skinnier, doesn't it? Okay? You're taking this absolute value function and you're going to make it that red, so you're stretching it. That's a stretch. All right, now let's look at what a compression is. A compression would be the other way. So you're moving it towards that x-axis. So you're vertically compressing. This is a vertical stretch. This would be a vertical compression. All right, so that distance, see how that distance, this point here, is 2 units, and when you multiply the y-coordinate by a factor of 2, which is what this is, by a factor of 2, you increase that distance by that same amount. So 2 units, a total of 4. 3 units, 3 units right here. 1, 2, 3, total of 6 units. 4 units, 4 units, total of 8 units. Okay? All right, so that's a stretch. Make sure you understand that's a stretch. It looks skinnier than this one, right? All right, so you're pulling it towards the y-axis. Here you're pulling it away from the y-axis. That will be a compression, so you're compressing it. All right, this will be compressing when you move it towards the x-axis, away from the y-axis. So let's look at that idea. So you may say, well, what must this number be in order for it to be a compression? All right, so let's look at this. So let's graph and put this maybe right here. Let me use another sheet of paper. So let's graph h of x equals 1/2 f of x. So 1/2 f of x. So let's look at 1/2. So I want you to notice this number is greater than 1. You see this? This number is less than 1. You'll see that? 1/2 is less than 1. Okay? When you look at f of x, that coefficient right here is 1, right? This is a 2. So 2 is greater than 1. 1/2 is less than 1. All right? So let's see what happens if we look at a number that we're multiplying f of x by that's less than 1. All right, I want you to think about this for a moment. Let's look at those y values again. That's on the absolute value function. This y value is 1. 1 times a half. So if x is 1, 1 times a half is a half, right? If x is 3, 3 times a half is 3 halves, or 1.5. If x is 4, 4 times a half, 4 times a half is 2. So that'll be 2 right here, correct? That's 2. So I want you to notice what's happening. I'm going to use a orange color for that one. So 1 half is right here. See that? 3, 1.5 is right here. 4, I'll make sure I'm using the correct point here. 4, and then 2 is right here. So when you look at it, and the same thing on this side, let me go ahead and label this right here as negative 2, 2. All right. So 2 times a half is 1, correct? I'm sorry. Yeah, 2 times a half is 1. So if x is negative 2, the y value better be 1, because 2 times a half is 1. So I get this point right here, which is negative 2, negative 2, 1, negative 2, 1, which is right here. Okay? And then we saw that this right here, I know I have points all over the place, but this right here, negative 4, 4, negative 4, 4. So if I take half of this 4, they'll become negative 4, 2. So it'll be right here. So if I look at that graph, and 0, 0 stays 0, 0, because remember when x is 0, my y value is 0 here, right? So half of 0 is still 0. So that stays the origin. So when I graph this, I get this. And what I'm about to graph is a compression. That is a compression. All right, so let me make sure I don't. Okay, I got to do this as best I can. All right, so this orange graph is a compression. All right, so this right here is h of x, which is 1/2 f of x. All right, so notice I've taken the blue graph right here, which is the absolute value function, and I'm compressing it, and I want you to notice, that basically what's happening is this. So remember right here, I went from here to here, right? So I took 3 and I multiplied by half. Multiplying by half is the same thing as dividing by 2. So I'm stretching vertically. This is stretching vertically by a factor of 2 because multiplying by half means to divide by 2. All right, so notice that distance here is halved. So I divided that distance by how many? By 2. So this distance went from 2 right here to 1, correct? So I took 2, that y value 2, see that y value 2 divided by 2, and I got 1. I took this y value 3 divided by 2, and I got 1.5. I took this y value 4 divided by 2, because remember, multiplying by half is the same thing as dividing by 2. Okay? I hope you see that. So I hope you remember that. So look, this means the same thing as f of x divided by 2. 1/2 times f of x means f of x divided by 2. So multiplying by half means the same thing as dividing by 2. So 4 divided by 2 is 2. So you see right here? So that distance went from 4 to 2 units. Okay? So that's compression. So this red graph right here is a vertical stretch, and this is a vertical compression. All right. Now, it does have something to do with this number right here, and I alluded to that earlier. So remember, this coefficient here is understood to be 1. This is 2. If that constant is greater than 1, you're going to be stretching, because if it's greater than 1, you're going to be multiplying those y values by that number that's greater than 1, which make those y values bigger. So those y values become bigger. Here, when you multiply by a number that's less than 1, those y values become smaller. I went from 3 to 1.5. I went from 4 to 2. They become smaller, so that's a vertical compression. All right, now that takes us to this. Okay, given a function f of x, a new function g of x, which can be written as a number other than 1 times f of x, where a is a constant, is a vertical stretch or a vertical compression. So if you have a number outside of that function being multiplied by that function, f of x, then that's either going to be a vertical stretch or a vertical compression. If a is greater than 1, it's a vertical stretch. If a is between 0 and 1, meaning less than 1, but still positive, then it's a vertical compression. Now remember, it is possible for a to be negative, and so that's where you have to remember that if there's a negative out in front, if a is negative, that's also a vertical reflection. All right, so if a is less than 0, you would need to cover up that negative for a moment and then determine whether it's a vertical stretch or vertical compression. The fact that it's negative would also imply that there's a vertical reflection. Okay? All right, so let's look at some examples. Let's look at this example. Okay, so let's look at this example. So here is the graph of function f of x. We're going to call this f of x. And what I want to do is I want to graph this function here, y equals 3 f of x. And I also want to graph this. So we're going to graph two things. I want to graph 3 times f of x, and I want to graph y equal, let's say this is h of x, equal 1/3 f of x. And let's call this g of x here. Okay, so this is g of x. This will be h of x. All right. Now remember that f of x, to do this, you gotta remember what f of x is. So this f of x is this y value. So you can take all these y values and you're going to multiply by either 3 or 1/3. Okay, now based on our discussion, you know that if you take f of x and you multiply by 3 and 3 is greater than 1, right, that's going to be a vertical stretch. Okay, if you take y and multiply by 1/3, which is less than 1, that's going to be a vertical compression. So you're basically going to be compressing it towards the x-axis. All right. So this will be skinnier for 1/3 and larger for 3. All right. Now it helps if you label those points. So I'm going to use those points here. So those are segments, some nice numbers. I'm going to use those points. So this is let's see, this point here is -6, negative, I did not mean that to be -5. I apologize, but I'm going to have to stay with that. I meant that to be a nice number, and it's not. So it'll be -6, -5. I do apologize for that. And then here, that's going to be -2, 3. And then here, that's going to be 3, 3. And then here, that's going to be 6, -3. Okay, 6, -3. This is the one that we're going to have to estimate right here, because that's a -5. And you'll see why we're going to have to estimate that. So that's -6, -5. Okay, so here we go. So this is going to be the, let's do the orange one first. So g of x equals 3 f of x. So you're going to take each of those y values and you're going to multiply it by 3, right? So negative 5 times 3 is a negative 15. So this becomes negative 6, negative 15, correct? Now notice that I only go up to 9, so we have to estimate. So that's 9, 10, 11, 12, 13, 14, 15. So do the best you can with estimating this. All right, so it's going to be about here. Okay? So this point becomes this point. So notice this distance here is 5 units, right? So we're going to multiply that distance by 3, and I'm going to get that distance here to be 15 now. Okay? All right. Now let's get this point here. This right here is negative 2, 3. I'm going to take this y value multiplied by 3. So 3 times 3 is 9. So that becomes negative 2, 9, which is right here. Okay, so this point right here, becomes this, and this point here becomes this. And if I connect them at this point, because that's a segment, right? So a segment becomes a segment. I don't have a ruler long enough. I don't think it'll do. So when I do that, I'm going to get this. Okay, so that segment I stretch. So I stretch that segment. That's what I'm doing. I'm stretching vertically that segment. Okay, so see, it became larger. That segment here became larger. The same thing here. When I do 3, 3, I take this y value 3, multiply by 3, I get 9. So I get the point 3, 9 right here. Okay, and then that segment's easy to draw. Okay, and then when I take this y value here, which is negative 3, multiplied by 3, I get negative 9. So that becomes 6, negative 9, which is about right here. Okay, and so when I connect those, when I connect this dot with this dot, or when I connect those 2 points, I get this. All right, and you can't see it, so let me go ahead and make it a little bit smaller. So that orange graph that you see, that orange graph, is a vertical stretch of that blue graph. All right, so this part, the part that's above the x-axis, see those y values are positive. So that's why we're stretching it towards the y-axis, the positive y-axis. Here, those y values are negative. So when I stretch them, the y values are still going to be negative. So I'm stretching them towards the y-axis. Okay? All right, so that's a vertical stretch. When I look at this in terms of that 1/3, which is going to be a vertical compression, let's see what we get. For vertical compression, so I'm going to take this y value, that's one where we're going to estimate. We're going to take this y value multiplied by 1/3, so that's negative 5/3. So negative 5/3 on your calculator, negative 5 divided by 3 is about negative 1.6, negative 1 2/3, right? Negative 1 2/3. So negative 1 2/3 is about right here. Okay, right here. So the point negative 6, negative 5 became the point negative 6, negative 1 2/3. This one's a little bit easier because 3 is divisible by 3. So 3 times 1/3 is 1. So the point negative 2, 3 becomes negative 2, 1. So I want you to notice, though, what's happening is that this distance here, I'm dividing it by 3. All right, so I'm taking 1/3 of that distance. Taking 1/3 of that distance. So 1/3 of this distance is this distance right here. 1/3 of this distance is this distance right here. See that? That's easy to see because that's 3 little units. So 3 divided by 3, or 3 times 1/3 is 1. So you got 1 unit right here. And then if I connect those 2 points, I get this segment right here. So this blue segment when I compress it, so remember compressing, you're moving it towards the x-axis. So this right here, you're moving it towards the x-axis. So that point becomes this point becomes that point. But notice that this segment became smaller. You see that? That segment became smaller. And if I do this point here, 3, 3, so I take the y value, multiply by a third. 3 times a third is 1, so I get 3, 1, which is right here. Okay? And then if I take this point here, which is negative 6, negative 3, negative 3 times a third is negative 1. So I get 6, negative 1, which is right here. And then if I connect this endpoint with this point, I'm going to get a graph that has been compressed. All right. So notice this blue graph, I compressed it. I vertically compressed it. So I vertically compressed it. See that? You vertically compressed it. So it looks smaller. A vertical stretch makes the graph look larger. A vertical compression makes it look smaller. See that? Okay. In terms of that space between the x-axis, you can easily see that. All right, so that is this idea that we talked about, and that's this. So if a is greater than 1 is a vertical stretch. If a is between 0 and 1, so meaning a proper fraction, then it'll be a vertical compression. And if it's negative, you know it's going to be a vertical reflection, but you are going to have one of these. So you just have to look and see if the absolute value of a is greater than 1 or if it's between 0 and 1. All right. So let's look at another example that's a little bit different than the graphs. So let's look at this example. All right. So let's look at this, and it's a very similar question as to what we looked at in previous lessons. So you want to describe the transformations of the following graph. And you're told that y equals 2 times f of x minus 4 plus 3. I want you to notice that there are 3 transformations occurring. There's this 2 right here that's being multiplied by f of x, or f of x minus 4. So, and notice that this 2 is greater than 1. So that's going to be a vertical stretch. You have a 4 that's inside this parenthesis, so you know that's going to be a horizontal translation. And then you have this 3 that's on the outside, so you know that's going to be a vertical translation. Okay, so stretch, horizontal translation or shift, and then vertical shift. Okay, all right. So let's go ahead and write down the answer. So you're going to and remember, you always go from left to right, and always do vertical translations last. So I'm going to vertically stretch f of x, and you must say the following. You must say what I'm about to say. Vertically stretch f of x by a factor of 2. By a factor of 2. So vertically stretch f of x by a factor of 2. You must use those words, by a factor. By a factor. You must use that. Then shift. Now let's see if you remember if this is going to be 4 units to the left or 4 units to the right. So remember f of x minus h, right? F of x minus h. All right, and so that's going to be, since h is positive, will be shift horizontally to the right 4 units. So shift to the right 4 units. And then this k is always the easiest. It's positive, so intuitively you know you're going to shift it up 3 units. Then shift up 3 units. Okay? All right, so what we have so far is this. We have y equals a times f of x minus h plus k. So this a right here determines the vertical stretch or compression. So that's stretch, and I should say vertical because there is a horizontal as well that we haven't talked about yet. So vertical vertical stretch or compression. Okay, this H is the horizontal translation, and the K is the vertical translation. Okay, all right, let's look at this next example. All right, so we have y equals negative 3. Notice there's a negative now, times f of x plus 2 minus 5. So there's 4 transformations occurring. 4 transformations. So remember, there's a negative out in front. That's a vertical reflection. That's a reflection about the x-axis. 3. So cover up the negative and just look at that absolute value of negative 3. So the absolute value of negative 3 is 3. So 3, since 3 is greater than 1, that's going to be a vertical stretch. This is going to be a horizontal translation, and that's going to be a vertical translation. Okay? All right, so go from left to right. So your answer, you're going to say reflect f of x across or about the x-axis, right? Okay. Then vertically stretch by a factor. You must say by a factor of 3. Don't say negative 3, because the negative is this right here. So always remember that. So you do 1, 2, 3, 4. 1, 2, 3, 4. 4 transformations. The reflecting about the x-axis, the vertical stretch, the horizontal translation, and the vertical translation. Okay, then shift to, all right, now remember, be careful with the horizontal translation. You got to remember that this means the same thing as saying negative 3 times f of x minus a negative 2. So remember x minus h. So h in this case is a negative 2. Okay? So you got to shift to the left 2 units. So shift to the left 2 units. And then finally, the last transformation is you're going to shift down 5 units. Then shift down 5 units. Okay? All right, let's look at this one. Okay, so let's look at this one. Now, here we have y equals 1/5. So you know that's going to be a vertical compression because that's 1/5 is less than 1. It's a proper fraction. Remember, proper fraction is a fraction less than 1. Times f of x minus 4 plus 3. So you know you have 3 transformations. A vertical compression, a horizontal shift, and a vertical shift. I'm going to say this right now. Whenever this number is less than 1, I've noticed that the platform you're using and the book you're using are inconsistent with the terminology. So here's the way I want you to do this. So remember, this means, this right here means you're going to take whatever that y value is here, you're going to multiply by 1/5. Remember, we have talked about that. So basically remember this right here. So this y value, you're going to multiply by 1/3. So we took each of those y values, 3, and multiplied by 1/3. And we got this point right here. Okay, so 3 divided by 3 times 1/3 is 1. All right, so we got the 0.31. All right, so notice that this distance was 3, right? And now this distance is 1. Okay, so I took 3 and I multiplied it by 1/3, or divided by 3. 3 divided by 3 is 1. So remember, multiplying by 1/3 means the same thing as dividing by 3. So when we talk about the way to write this, listen carefully to what I'm going to say. So in the Nun Alta, the questions will be similar to what I'm going to write down. So we know there's a vertical compression. So the way I want you to write this is this way. So you're going to, so the answer will be, you're going to vertically compress. You must use the word vertically compress, okay? You must use that. Vertically compress by a factor, just like before, by a factor of, now don't say 1/5. So remember, multiplying by 1/5 means the same thing as dividing by the reciprocal, which is the reciprocal of 1/5 is 5. So the reciprocal of 5. So say by a factor of 5. All right. So vertically compress by a factor of 5. All right. So remember, in a previous problem here, we said vertically stretch by a factor of 2. So stretch by a factor of 2. Vertically stretch by a factor of 2. And you may say, well, why in here I didn't take the reciprocal, but in the other one I did? Well, remember, if this number is greater than 1, when this number is greater than 1, you are basically multiplying those y values by in this case 3, which triples that distance. So you are multiplying by 3. It's tripling that distance. Here, when you do the 1/3, when you multiply by 1/3, you are dividing that distance by 3. So let's go ahead. I know it's confusing, but when you do that assignment, you're going to notice that they're not going to use 1/3. They're going to use the reciprocal of 1/3, which is 3. So I just don't want you to get too hung up on that. So you're going to say vertically compressed by a factor of the reciprocal of this is 5. All right, so that's going to be a little bit challenging for you when you look at the problems that you're going to see in that Newton-Alta assignment. So vertically compressed by a factor of 5. And so then, and when I say vertically compress, I mean vertically compress f of x, right? So you got to say f of x. Then shift, remember x minus h is 4, so that's positive. Vertically shift to the right 4 units, and then up, k is positive 3, so up 3 units. Okay, so be careful when this number is less than 1. To be on the safe side, just go ahead and be consistent with what Newton-Alta has. So they have vertically compressed by a factor of, so whenever it's a compression, take the reciprocal of this. So you say vertically compressed by a factor of 5. All right, let's do one more so where you can see what I'm saying. So if I have y equals negative 1/4 f of x plus 2, let's say minus 5. So there's 1, 2, 3, 4. 4 transformations. So the first thing you're going to do is that vertical reflection. So you're going to reflect about the x-axis. So answer. So reflect f of x across the x-axis. Okay. Then cover that negative symbol and look at that 1/4. That's less than 1, so you know that's going to be a vertical compression. So you're going to say then vertically compress by a factor of, and then take the reciprocal. The reciprocal 1/4 is 4. So multiplying this by 1/4 means the same thing as dividing by 4. Okay? So that's a more challenging one here. You got to remember that. That's the way that if you look at when you do the assignment in Newton-Alta, when it's compression, that's the way they're going to write it. They're not going to put 1/4. They're going to put the reciprocal of that, which is 4. Okay. All right. Then the rest is easy. X minus a negative 2. All right. So remember, be careful with the horizontal translation. So then shift to the left 2 units, and then shift down 5 units. Okay. All right. So that is our lesson on vertical stretches and vertical compressions. Okay. So that's it. That's the lesson.